Hello everyone. So in this video I want to cover how to get a series in closed form. And of course this is just going to be specific to this one series, but I'll have other videos going over things similar to this. But you've probably seen at some point that if we take a positive integer n and we want to sum up all of the numbers up to that, then we get this formula n times n plus 1 over 2. And the question you may have is, where does this come from? This seems to be another thing that is just kind of thrown at us without any sort of explanation. And I want to start this with a story about a mathematician named Gauss, who as a kid it said was given this problem by his teacher. And his teacher asked him to sum up all of the numbers to 100. And so we're just going to write that here. And what Gauss realized is, one, this is going to take a long time if you actually sit down and do 1 plus 2 plus 3 all the way up to 100. But he realized something rather interesting. And that is that if I take 1 plus 100, that's just going to be equal to 101. If I take 2 plus 99, that's also going to be equal to 101. And if I take 3 plus 98, that's also going to be equal to 101. And this goes all the way down, right? And so what we know here is that we have n over 2 summations, of course, if this is even, right, times 101, right? So this is really just 101 times, well, the number of actual objects we're dealing with divided by 2. In this case, it's 100. And so this is just 50 times 101, right? And so now I've got a way to do this very, very fast by just using a little bit of logic. And in fact, we can do this in general, right, by taking the same idea, 1 plus 2 plus 3, all the way up to n minus 2 plus n minus 1 plus n. And notice we get the same thing. If I add 1 to n, that's going to give me n plus 1. If I add 2 to n minus 1, that is going to give me n plus 1. Continuing on, n plus 1. And in fact, I'm going to have n over 2 of these sums, right? And so we just have n plus 1, or n times n plus 1 over 2. And notice that it doesn't matter. You may look at this and say, okay, well, what if I have an odd number of sums? It doesn't matter, because if n is odd, n plus 2 is going to be even, which means it's divisible by 2. If n is even, then n is obviously divisible by 2. And so you will always get an integer for this. And again, this is a really important thing in mathematics of, can I take something which seems to go on and put it in what's called a closed form like this? So very simple proof of